All right, we are on Module 5, Lesson 13. Module 5, Lesson 13. Today we are going to multiply mixed numbers and understand how the distributive property and the area model use those multiplication skills. So, if you want to practice your fluency today with fractions, go ahead and pause the video and copy these down. Here's another fluency for you. Trying to find the volume of that. Remember, we have length times width times height. So width is kind of like how deep it is, right? There's another volume of a prism you can practice. And the last one. Okay, we just did our application problem here. And here we go. So, practice problem number 1 for your concept development today. It says find the area of a rectangle that measures 1 1/3 inches times 3 3/4 inches. Use the area model to find the area. So I'm going to draw that one over here. So we have 1 1/3 times 3 3/4. Okay, and remember when we are doing the area model, we decompose this into 1 plus 1/3 and 3 plus 3/4. Okay, so area model looks like this. Okay, area model looks like this. And then we multiply, and then we'll add together our totals. So 3 times 1 is 3. 3 times 1/3 is 3/3, which is 1. 1 times 3/4 is 3/4. And 1/3 times 3/4 is 3/12. So now we're going to add all of these together. So area, we have 3 plus 1 plus 3/4 plus 3/12. 3 plus 1 is 4. And then 3/4 and 3/12 do not have the same denominator, so we're going to turn 3/4 into 12ths. 4. So 4 times 3 gets us to 12. So whatever we do at the bottom, we do to the top. 3 times 3 is 9. So 3/4 is the same as 9/12 plus, now we're going to add this 3/12 back in, which equals 12/12, which equals 1. So we have 4 plus 1, which gives us 5 inches squared. Don't forget your label. Okay, so that is finding the area using area model. Using area model. So now we're going to find the area of that rectangle in a different way. Okay, we're going to find this area in a different way. I'm going to present this. Okay, so I'm just going to scroll down. Okay, so we're going to find that area of the rectangle in a different way. So we have the same 1 1/3, 3 3/4. Okay, 1 1/3, 3 3/4 is that side. So what is 1/3 expressed only as thirds? 1 1/3 only as thirds. 4/3, right? So this is the same as 4/3. And what is 3 3/4 expressed only as fourths. 15 fourths. 15 fourths. Okay, so exactly what it shows here. So now we have 4/3 inches and 15 fourths inches. And when you solve for area, it's going to look something like this. So now we have 4/3 area, 4/3 times 15 fourths. I'm going to make this look like more like a multiplication sign. Okay, so now we have 4 times, which equals 4 times 15 over 3 times 4. Okay, we have 4 goes into 4 one time. So now we have 1 times 15, which equals 15, over 3 times 1, which is 3, 15 thirds. 3 goes into 15, 5 times, so our area is 5 inches squared. So that we just got the same answer as we got up here. Here's our 5 inches squared by just using numbers and multiplying a different way. So what we did was we turned our mixed number, here's our mixed number, and we turned them into improper fractions. And then we just multiplied. All right. So which way of finding area worked best for you? And would there be times that either strategy might be the best choice? Possibly. Okay, so now we're going to move on to problem number 2. Problem number 2. So what you're going to do is you're going to take notes like you normally do every day. You should have been taking notes. You're going to draw a rectangle with the sides of 16 1/2 and 4 1/4. And these are in inches. Okay, so they don't have to be exact. We're just going here, okay, 16 1/2 and 4 1/4. So I'm going to draw 2 of them because we're going to do it both ways here. Okay, so the first one we're going to do the area model on the top. So we have to take our 16 1/2 and break that apart. So we have 16 and then 1/2. And we have 4 1/4. And then you multiply. 16 times 4 is 64 inches squared. 4 times 1/2 is 2 inches squared. 1/4 times 16 is 4 inches squared. And then 1/4 times 1/2 is 1/8 inches squared. And then when you add those together, you get, I just kind of add the top here. So 64 plus 2 is 66 plus, and then we can add the bottom here, which is 4 1/8. So 66 plus 4 1/8, which gives us a total of 70 1/8 inches squared. So that's the area model. And then now we're going to do the second way, where we turned our number 16 and 1/2, and we turned it into halves. So how many halves is that? Remember, it's 2 times 16 and then plus 1. So you multiply the denominator and the whole, and then you add 1 and you keep that denominator. So I'm going to do that again. 16 times 2 plus 1, which is 32, plus 1, which is 33 halves. And then we take 4 and 1/4. Okay, and 4 times 4 is 16, plus 1 is 17, and you keep the denominator, 17 fourths. So now we're just working with 33 halves times 17 fourths. So 33 halves times 17 fourths. This is our area. (33 times 17). 7 times 3 is 21. 1 carry the 2. 7 times 3 is 21 plus 2, which is 23. Placeholder 0. 3 times 1 is 3. 3 times 1 is 3. And then you add them together and you get 561. So we have 561 on the top over 2 times 4 is 8. So 561 eighths. 8 goes into 561 how many times? It's really hard to do in your head, so then you have to go division 8. I'm going to move this down. So we have 8 into 561. 8 doesn't go into 5, but it goes into 56. 8 times 7 is 56. 0. 8 doesn't go into 0. Bring down the 1. And remember, this is our fraction, 1/8. So this is 70 and 1/8. So your answer is 70 and 1/8. And both of our answers, they match. We have 70. We have 70 and 1/8 here, and 70 and 1/8 here. And which way made more sense to you? Me, I like the area model better because I didn't have to do this multiplication and division in the area model. So for me, the area model worked best for me for that problem. So what this does is it kind of shows you exactly what I just did. Okay, if you look at the area model, it looks like a lot less work than the second way that I showed you. For some of you, it might be easier. For some of you, it might be harder. But remember, there are lots of different ways to do this. So you're going to repeat this process for a square with sides that measure 3 2/3 inches. So what I want you to do is I want you to do this all by yourself. Pause the video. You're going to do both strategies and tell us what strategies worked best for you. So you're going to draw a square. Square, remember, the same sides. So 3 2/3 and 3 2/3. You can turn these into thirds, or you can do the area model. So go ahead and pause the video and then unpause it for your answer. Okay, so this is actually problem number 4 that I just did on, I don't know how to go back. So anyways, area model would look like this. We would have 3 times 3, which is 9, 3 times 2/3, which is 6/3, 3 times 2/3, which is 6/3, and then 2/3 times 2/3, which is 4/9. Well, we know that 6/3 is the same as 2. So this is also 2. This is also 2. So we have 9 plus 2, which is 11. We have 11 plus, and then 2 plus 4/9, which is 2 and 4/9. So 11 plus 2 and 4/9 is 13 and 4/9 meters squared. To me, that way was pretty easy. If you turn it into thirds, sorry, all my phone's going off. If you turn this same square into thirds, 3 and 2/3 is the same as 11/3, right? 3 times 3 is 9, plus 2 is 11, and you keep the denominator. So 3 and 2/3 is the same as 11/3. You have 11/3 times 11/3. So you have 11 times 11 over 3 times 3. 11 times 11 is 121. 3 times 3 is 9. And there's your answer, 121 over 9 meters squared. Okay, 9 goes into 120. Then you would have to do your division. 9 into 121. 9 goes into 12. 1 time. 9 times 1 is 9. 3. 9 doesn't go into 3. But it does go into 31. 3 times, which is 27. And then you subtract 31 minus 27. Which is 4/9. So then you get 4 over 9 as your fraction. So you get the same answer, 3 and 4/9, as you do up here. But which way was easier to you? You get to pick. And then the last one here is problem number 3, or problem number 4. This is your last problem for today. An 8-inch by 10-inch picture is resting on a mat. 3/4 inch of the mat shows around the entire edge of the picture. Find the area of the mat not covered. So again, you have 8 by 10. So we know that this is 8 by 10. And then we also know that the area in between here is 3/4 inch. Same in between here is 3/4 inch on each side. So if you look over at the presentation, it gives you the area of the mat. So the area of the mat is a 9 by 9.5 by 11.5. Okay, and how they got that is they added 3/4 inch here and here to 8. So 8 plus 3/4 plus 3/4 gives you 9 inches. Three-fourths plus 3/4 is 6/4, which is 1.5, or 2.5. No, 3.5. I'm sorry. 3/4 plus 3/4 equals 6/4, 4, and 4/4 is 1 and 1/2. So that's how they get 8 plus 1.5, which equals 9.5. And then we have 10 plus 3/4 plus 3/4. And we know that 3/4 plus 3/4 is 6/4, which equals 1.5. So we have 10 plus 1.5, which gives us 11.5. So if you look at the presentation, that's why they have 9.5 by 11.5 is the area of the mat. And when you do the area model, you get 104.5 inches plus 4 3/4 inches, which is 109 1/4 inches squared. So you have to take that and then subtract the total area of the frame, which is an 8 by 10, which is 80. And that gives you 29 1/4 of an inch. So that tells you that the area of the mat that is not covered by the picture, so the area of the mat not covered by the picture is this part, just this area, is 29 1/4 inches squared. So they did that in an area model, and then they also did that in a tape diagram, which is awesome. So they drew a tape diagram of the actual picture frame, which is 80 inches squared. And they know that the area of the mat is 109 1/4 inches squared. And so there's a little piece there that was not covered. All right, so your problem set is an extension activity, remember? So if you want to do that for extra help, you can. Here are some debrief questions to think about. What are the strategies that we have used to find the area of a rectangle? I did 2 today. So which one do you find the easiest, the most difficult? How would you decide which strategy you would use for a certain problem? Remember, it's all about having multiple strategies. Not one strategy is always the right answer. Okay? And then your exit ticket for today. Find the area of the following rectangles. You can draw an area model if it helps, but you do not have to. Remember, we want to relate this back to the distributive property, which we're going to relate it back to this first problem. Okay, so we have 1 1/3 times 3 3/4. 1 1/3, 3 and then 3/4. Okay, how does the area model, relate to the distributive property? And I'm going to show you. So 1 1/3 times 3 3/4. So the distributive property is when you multiply the wholes, right? The wholes, whoops, and then 3 times 1/3, and then you multiply So 3 times 1, which is 3. 3 times 1/3, which is 3/3, which gives you 1. So 1 times 3 plus 1/3 times 3. This is that distributive property. And then on the bottom here, we have 1 times 3/4. And then we have 1/3 times 3/4. So that's our distributive property there. And then you add those together, and we got this equals 4, and this equals 1. So 4 plus 1 equals 5 inches squared. So this part is the distributive property. So you can do your exit ticket with that distributive property with just your numbers and your equations, or you can draw an area model. It is your choice.